Hey y'all, I didn't want you to be behind, so I made a video. All right, we're gonna go over transverse and longitudinal waves. Okay, energy transfer. We've already talked about this. Energy transfer can be transferred in the form of waves. We haven't really talked about that, but we do know that energy transfers. Energy transfer is the movement of energy from one object or location to another. Most of this happens because of waves. Some waves transfer energy through a medium. A medium is a substance through which a wave moves. Can be a solid, liquid, or gas. Can you think of an example for each? Go ahead and write it on the back of your notes. Just an example for each of a medium that you can think of that goes between a solid, a liquid, and a gas.
Forms of energy, sound and light. And we want to see if you can try making your own. All right, welcome to Fun Science Demos. Today we want to take a look at two forms of energy, sound and light. And we want to see how those forms of energy move. Both sound energy and light energy travel in waves, and sound waves are a lot slower than light waves. Light waves travel really, really fast. That's why when we see the light from a lightning bolt, it's always before we hear the sound waves of the thunder. So we can use this slinky to show you how sound waves and light waves travel. I'm going to put some energy into this slinky, and I want you to watch how that energy bounces back and forth down the slinky. Watch how it moves. If you look carefully, you can watch the energy move in waves down the slinky and bounce back and forth. That slinky was cool, but we wanted to make a different wave machine to show you how energy travels in waves. To do that, we used duct tape, plain wooden sticks, and lots of candy. Now we're going to take this outside, stretch the wave machine out, and put some energy into the wave machine so you can see how it works. So now we get to see this wave machine in action. A wave is energy, so I need to add some energy to this wave machine, and when I do that, I want you to watch that energy move down the machine from one end back to the other. Watch. Did you see the energy move down the machine and then back down the machine and back toward me? Remember, sound and light are both energy, and they travel in waves a lot like this. Sound energy and light energy are traveling in waves. Let's see what happens when we add more energy to our wave machine. Get a nice, clean, crisp wave that travels down the machine and back and down and back and down and back. The candy wave machine. It was so cool to see how that wave energy traveled down that wave machine. But if you wanted to explore waves on your own, there's a great simulation put out by the people from FET. And we're going to zoom in and explore it a little bit to see what that.
So that's kind of an introduction to it. Where we might, if we have time, we'll do that simulation, but not today.
Hi, I'm Jared.
Okay, transverse waves. Oh, I missed one. No, I didn't. So there are two types of waves, longitudinal and transverse. Transverse waves is a type of wave which displacement from the resting point is perpendicular to the direction the wave is traveling. So the displacement from the resting point. So we're going to go up and down, all right? That's perpendicular because our line goes horizontal and our wave goes up and down. That is what that means. I know it's very, very confusing the way that it's phrased. It just means up and down. If the energy transfers left to right across a room, the medium or magnetic or electrical fields, in the case of electromagnetic radiation, vibrates up and down from the resting point, okay? So visible light, like light from a television, from the screen, from our light bulbs outside. These are all types of transverse waves, any kind of visible light. There's light waves, ocean waves, and vibrations on a guitar string. All of these are transverse waves. Not all transverse waves require a medium. And as you remember, a medium is something that it travels through. So we already talked about, some can move through solids, liquids, and gases. But electromagnetic waves are an example of a transverse wave that do not require a medium because, look, it goes through outer space. Through outer space. All right? There's no medium in outer space. We don't have gravity. We don't have air. There's no oxygen. There's no medium that goes through outer space. So it goes through the vacuum in space, our atmosphere, and water. Visible light. That's what electromagnetic waves are. Electromagnetic waves are visible light. Longitudinal waves are a type of wave in which movement from the rest position is parallel to the direction the wave is traveling. So like music, we go across. Our wave goes across. It doesn't go up and down, it goes across. All right? It's also known as a compressional wave, transfers any energy in the same direction that the medium vibrates. Sound is a longitudinal wave. Okay? Examples of longitudinal waves: sound, ultrasound, ultrasound, and the stretching and compressing of a spring. Okay? All of these are examples. So they require a medium all the time. Longitudinal waves always require a medium, whereas transverse do not. They cannot travel through a vacuum, so they cannot travel through space. If you are in space, you can't hear anything around you. All right? The people in space, they have helmets that allow them to listen, but they can't hear anything around them. Okay, we're gonna watch a couple more videos. You can actually watch these on your own. They're really good information, okay?
In a longitude.
So, on the back of your notes, you're going to identify which types of waves these are. All right? When I come back on Monday, we'll go over them and talk about what they are. So, we've already talked about a lot of these. So, on the back, you're going to go A through F, and then you've got one more video to watch. Y'all do the best you can, and I hope this video is very helpful to you. I'm so glad that y'all were well behaved.